Hi everybody. I am currently in the building, but I am proctoring the park exam, so I'm going to give this a try. If you do need to find me, I should be off 5th and 6th hour as usual. And also at any point, if you feel like this is going too quickly, feel free to hit pause, and I will be uploading this to Schoology so you can go back to it. Yesterday we talked about sequences in series, and today we're going to talk about some specific types of sequences, arithmetic and geometric. Okay, so our first one, we've got 2, 4, 6, 8, 10. So hopefully you notice that there's a pattern here. To go from 2 to 4 to 6 to 8 and so forth, we are adding 2. Sorry, it's a little sloppy. And likewise in the next one, I go from 10 to 6 to 2 to negative 2 to negative 6. So that is going down by 4. So I'm subtracting negative 4 for my first term to get to my next and so forth. So the definition of an arithmetic sequence is a sequence in which each term after the first term, our a sub 1, is equal to the sum of the preceding term and the common difference. So that common difference in the first example was plus 2, and then the second example was minus 4. So just writing out that definition, what's going on here is they're saying we have some a sub 1. Our second term is a sub 1 plus that common difference. Then I could do a sub 1 plus d, which is really the same as a sub 1 plus 2d, a sub 1 plus 3d, and so forth. Well, how do you come up with that common difference? Well, it should be pretty obvious. We just figured out what was being added, but you can always take a sub n plus 1 and subtract a sub n. What that is, you're subtracting any term from its succeeding term. Okay, so the first two examples are nice and easy. Find the common difference, d, and the next three terms. Now, normally I'd have you guys try these on your own, but hard when I'm on a recording. So let's see, we've got 5, 10, 15. Hopefully you know how to do this without any work, but I'm going to say our d is found by taking 10 minus 5 or 15 minus 10. Either one would be fine, and we come up with d equaling 5. So there's the first thing that they wanted. And then find the next terms. Well, based on what the definition of an arithmetic sequence was, if I have that common d of 5, my next three terms will be 15 plus 5, or 20, 25 plus 20, or excuse me, 20 plus 20, 20 plus 5, can't talk, is 25, and then 25 plus 5 is our 30. So there are our next three terms. Okay, next one, negative 8, negative 12, negative 16. I can tell that I'm going down by 4, but just in case, I can do negative 12 minus negative 8, which does give us a d of negative 4. And just like we did for the last one, I'm going to go ahead for my negative 16, and I'm going to go down 4 from there. Negative 20, negative 24, and negative 28. Now that process is okay when I just want the next three terms, but what if I said find me the 100th term or the 1000th term? I'm not going to sit there and continue to subtract 4 until I get to 100 or 1000. There has to be a formula. Once again, normally I'd have you guys derive this with me, but we don't have that luxury right now, so let me just move this down. Okay, so here we go. It's time to derive it. If a sub 1 is the first term of an arithmetic sequence and d is the common difference, find a sub n. Well, I'm just going to see if any patterns arise. Okay, our first term is a sub 1. So I'm just going to say a sub 1 equals, obviously, a sub 1. A sub 2 we know is our a sub 1 plus our common difference d. A sub 3 equals our a sub 2 plus d. But we know from what I wrote earlier that a sub 2 is really a sub 1 plus d plus d. So all I've done here is substituted in what a sub 2 is in for that a sub 2. And now I'm left with a sub 1 plus 2d. Okay, let's see. A sub 4, we know is our a sub 3 plus d. And once again, substituting in for a sub 3, we have quantity of a sub 1 plus 2d plus rd, which simplifies to a sub 1 plus 3d. So, anyone start to notice anything? Well, when I look at a sub 1, this is really like a sub 1 plus 0d. A sub 2 was a sub 1 plus 1d. A sub 3 was a sub 1 plus 2d. A sub 4 is a sub 1 plus 3d. Any guesses on what a sub 5 would be? Hopefully you're all thinking a sub 5 equals a sub 1 plus 4d. And we'll just show that real fast. A sub 5 equals our a sub 4 plus d. Since we're always building off the last one, that's a sub 1 plus 3d plus rd. And yep, we were right. A sub 1 plus 4d. Okay. Well, I don't have to keep going on this pattern for too long. I'd rather just have a formula. So therefore, our formula, if I'm looking for a sub n, so the nth term, well, it's obviously for all of these going to be a sub 1. Well, my a sub 5 was 4d, a sub 4 was 3d, so it's always my nth term, but it's the n minus 1. So I'm going to say a sub 1 plus the quantity of n minus 1 times d. Okay, so this is one of the 5 major formulas for this chapter that you have to know. A sub n equals a sub 1 plus n minus 1 times d. This can be used to find your last term, your first term, your number of terms, or your common difference. Okay, so we're going to start practicing a few, and please realize that there are different ways of doing these. We will talk more about these tomorrow. Okay, looking at our first one, find a sub 20 and a sub n for negative 3, negative 9, negative 15. So that's our sequence. Like I said, many different ways of doing this. Some people like to find their general formula that a sub n equals this, and then plug in for a sub 20. I want to get more practice just using our new arithmetic sequence formula, so I'm going to use that first to find a sub 20. Okay, so a sub 20 is my goal. And I guess before we get going, we should probably see what we notice about the sequence. From negative 3 to negative 9 to negative 15 has us going down by 6. So our d, so to find our 20th term, a sub 20 equals our a sub 1. Well, our first term was negative 3 plus the quantity. Well, now it's n minus 1. And I am looking for my 20th term, so n is 20. Therefore, I will do 20 minus 1 times that common difference of negative 6. Leaving us with a sub 20 equals negative 3 plus 19 times negative 6, which is negative 114. And I now know that a sub 20 equals negative 117. Much quicker than subtracting 6 all those times to get to your a sub 20. Okay, now like I said, you could have started out by finding your a sub n. So now I'm going to find my general formula that will work for me to find any term out there. So a sub n, we know, is our a sub 1 of negative 3. We're going to keep it in terms of n, so n minus 1 times our negative 6. And you always want to simplify. Therefore, this turns into a sub n equals negative 3 minus 6n plus 6, resulting in a sub n equals negative 6n plus 3. And I like to always just take a quick minute and check my work. If I were to plug in plug in 1 for my first term, I better get negative 3. If I were to plug in 3, my third term, I would get negative 18 plus 3, and I get negative 15. If I plugged in 20, I would get negative 120 plus 3, which is our negative 117. Just showing me that I've done both my a sub 20 and my a sub n, hopefully correct. Okay, the next one requires a little bit more work, and once again, there are different ways of going about this. Zoom in. Okay, what's different about this one is it still says find a sub 8 and a sub n for the arithmetic sequence having a sub 20 equals 18 and a sub 25 equals 38. So the difference here is I don't truly have my first term. But I do, in a sense. I can say that a sub 20 is the first term I know, and a sub 25 is the last term I know. Well, normally we're able to figure out our d pretty quickly. This is not going to be the case. So I'm going to actually use our formula first to figure that common difference out. So I'm going to write that out. So first need our d. Okay, so let's see. Like I said, I'm going to call a sub 20 my first term and a sub 25 my last term. Last term. So I'm going to say a sub n is 38 equals my a sub 1 of 18 plus. Now I need to know my n, my number of terms. The common mistake here is that people say n is 5 since we're going from 20 to 25. But the key thing is you always subtract them and add 1. So 25 minus 20 plus 1. And we end up with 6. So I now have 6 minus 1. Like I said, if you want to write that down, I figured that n out by doing 25 minus 20. Always have to add 1. So that's for your n. And now, with our formula, the one thing that we're looking for is our d. So simplifying this a little bit, we're going to get 38 equals 18 plus 5d. We're then going to subtract our 18 to get 20 equals 5d, and d equals 4. And my guess is you probably could have figured that out without using this formula, but that is how I use the formula. That's how I always use it. Okay, so next thing we need to do is, it would be nice if we could figure out what our a sub 1 actually is. Our first term they gave us was a sub 20, but I want to find the true a sub 1. So now I'm going to say find a sub 1. And you are welcome to use a sub 20 or a sub 25 as your last term. It doesn't matter because you'll take care of that with your n. So I'm just going to use my a sub 25 because that is truly the last one that I know. So I'm going to plug back into my formula. The last term I know is 38. I'm looking for my a sub 1, so 38 equals a sub 1 plus. Now I got to figure out my n. I am going from 1 to 25, which hopefully you're now saying is 25. 25 minus 1 plus 1. So my n is 25 minus 1, and we just found out that our d is 4. And we will get 38 equals a sub 1 plus 24 times 4, or 96. Subtracting away our 96, we end up with a sub 1 equaling negative 58. Okay, I think we're getting the hang of this formula, hopefully. So I'm going to go ahead and find the general formula before I find a sub 8. I don't care which path you take first. So now I'm going to go ahead and say I'm going to find our general formula for a sub n. a sub n equals, now I'm building it off of everything I already have. That a sub 1 we just found, so equals negative 58 plus the quantity of n minus 1 times our d from earlier of 4. A sub n then equals negative 58 plus 4n minus 4, giving us a sub n equals 4n minus 62. Before I find my a sub 8, I might take a quick second just to make sure that this works. Okay, if I put in 20, a sub 20, 5 times 20 is 80, minus 62 is sure enough 18. And I could check a sub 25, a sub 1, all that. Okay, last thing I need to do is find a sub 8. And I could go back to the original formula, a sub n equals a sub 1 plus the quantity of n minus 1 times d. But I'm very comfortable with the formula I just created, so I'm going to say now a sub 8 equals 4 times our n now of 8 minus 62. And we'll get a sub 8 equals 32 minus 62. And we will now have that a sub 8 equals negative 30. So as you can see, there's just a lot of manipulation of that formula that we came up with. Okay, so that's arithmetic sequence. Now it's time for geometric. Feel free to pause if I went too fast. I never know. Okay, so here is our geometric sequence. First example, 1, 2, 4, 8, 16. Hopefully, oops, I'll erase that. Hopefully you realize that each of these are being multiplied now by 2. Next one, let's see. I've got 3, 2, 4 thirds, 8 ninths. From 3 to 2, from 2 to 4 thirds, actually what it looks like I'm doing is it looks like I am multiplying by 2 thirds. So multiplying by 2 thirds, 2 thirds, and 2 thirds. Which gives us the definition. A sequence in which each term after the first is equal to the product of the preceding term and the common ratio. So as the arithmetic was a common difference, we're adding that same value. Here we have a common ratio. We are multiplying by a common number. So to find that common ratio, you have to do a sub n plus 1 divided by a sub n, which really says divide any term by its succeeding term. Okay, so let's look at our first example. Find the common ratio and the next 3 terms. Well, 3, 9, 27. Hopefully you can see our r is 3, but you can always use your formula. R equals, I'm going to take 9 divided by its succeeding term of 3, and I end up with our r of 3. Or I could have done 27 divided by 9. So I now know that r equals r3. And to find the next three terms, I'm going to take 27 times 3, 81. 81 times 3, or 243. And then 243 times 3, or 729. Next one looks a little trickier to figure out, but we have the formula. So I've got 2/5, negative 4/15, and 8/45. So r equals, I'm going to take my negative 4/15 divided by 2/5. And I know that's going to change into negative 4/5 times 5/2. Or excuse me, negative 4/15. And that will reduce to negative 2/3. And you will be allowed a calculator this chapter, so you could always go that route. My next three terms, I'm going to start from my 8/45. And my next term will be negative 16/135. Then take that negative 16 times 135 times negative 2/3 to give us 32/405. And then finally end up with negative 64/1215. Whenever you have a negative r, your terms will alternate in sign. Positive, negative, positive, negative. And just like the arithmetic sequence, it's fine if I'm only asking for the 6th term. But what if I'm asking for the 100th term? You will not take that time to continue multiplying by r. There has to be a formula. So we're going to go ahead once again and come up with that formula. Looks very much like what we did for arithmetic. Start with my a sub 1. Oops, I don't want that color. A sub 1 is just a sub 1. A sub 2 we know is our a sub 1 times r. A sub 3 is a sub 2 times r. And through substitution, we know that a sub 2 was a sub 1 times r. So that's our a sub 2 times r, which can be simplified into a sub 1 times r to the 2nd. A sub 4, this just goes on and on. We know is our a sub 3 times r. And by substitution, we know a sub 3 is a sub 1 times r to the 2nd. And then times our r gives us a sub 1 times r to the 3rd. Well, I think that's probably good. This is really saying our a sub 1 was a sub 1 times r to the 0, since r to the 0 is 1. A sub 2 is really a sub 1 times r to the 1st. A sub 3 is a sub 1 times r to the 2nd. And a sub 4 equals a sub 1 times r to the 3rd. Therefore, we can hopefully conclude that a sub n is a sub 1 times r to the what? N minus 1. This is the second of 5 formulas that you will need to use in this chapter. Okay, so let's finish it off with some examples. I always find geometric a little easier to work with. Okay, very similar as the front. find a sub 5 and a sub n for a sub 1 equals 8 and r equals -4. So right there, they're telling us we have an r. It is geometric. You can do it in either order. I'm just going to go ahead and practice with our formula a little bit more. So I'm going to start with our a sub 5. A sub 5 equals, well, that's our a sub n. It equals our a sub 1 of 8 times our r of -4 to the n minus 1. Well, if we're looking for our fifth term, our n is 5. So 5 minus 1. Be very careful that -4, that r must be in parentheses. So we've got a sub 5 equals 8 times -4 to the 4th. So right away I know this is going to be positive. So a sub 5 equals 2048. Okay, and then our general formula, a sub n equals r8 times -4 to the n minus 1. Do not simplify that. Do not make that -32 to the n minus 1 because they do not have a common base. So our a sub n is just that, 8 times -4 to the n minus 1. And then our last one, find a sub 1 and r for the geometric sequence having a sub 3 equals 25 and a sub n equaling 1 over 625. Okay, well, let's see. I'm not going to be able to figure out a sub 1 without our r, so I'm going to go ahead and find r first. So find r. Once again, I don't necessarily have my first term, but I can call a sub 3 my first term that I have, and a sub n my last term. So I'm going to say 1 over 625 is my last term, equals 25, which is my last term, times, we're looking for r. Be careful with our n. I'm going from 3 to 9. So 9 minus 3 plus 1, which is going to be 7 minus the 1. So if you need to take note of that, how I got that 7. It's last minus first, always plus 1. Which now simplifies into 1 over 625 equals 25 r to the 6th. I'm going to divide by 25, or actually I'm going to multiply by 1/25, same thing. I know that 625 is 5 to the 4th, and 25 is 5 squared, so this turns into 1 over 5 to the 6th equals r to the 6th. I'm going to raise each side now to the 1/6, and I will have 1/5 equals r. Uh-oh, where's my mistake? I just took essentially the 6th power, or excuse me, the 6th root, which means I need a plus or minus. Okay, so I've got that. Now it's time to find our a sub 1. I'm going to use my r, but I actually have to go ahead and use both of them. So if I'm going to say if my r equals 1/5, I don't care which one you pick. I'm just going to try to pick smallest number. So I'm going to say a sub 3 is my last. So I'm going to say 25 equals a sub 1 times our r of 1/5. And if I am going from term 1 to term 3, that's 3 minus 1 plus 1. So it's 3, and then plug in my formula, minus 1. 25 equals a sub 1 times 1/5 to the 2nd, which is 1/25. Multiply both sides by 25. And I end up with a sub 1 equaling 625. Well, now I got to try what if r equals negative 1/5. 25 equals a sub 1 times that negative 1/5 to the 3 minus 1. Nothing will change because this is now a negative 1/5 to the second power. Therefore, I'm not going to work through it all because it's the same as right above. My a sub 1 is no matter what 625 for either of the r's. Okay, once again, I will be at school if you guys have questions. I'll be available tomorrow morning as well. This will be on Schoology in case I went too fast. I apologize if I did. Try your best on tonight's homework, and I'll try to clear anything up tomorrow. Hope you guys have a great day. Bye.